Hi everybody, so this is a video based on a little snippet that I did on Twitter. I improved this implementation and here's the tutorial for it. Admittedly, Python is not the best language to do this kind of stuff. C++ is better for this, but the idea of this video is to learn Python classes, how to use them, and maybe Python is better to illustrate how linked lists work. So double linked lists are data structures that allows us to illustrate some good concepts in software development. So it's a cool concept to know and implement. Also, it's very useful concept for knowing graphs. But for now, let's see linked lists. So the basic idea is that we have a node that has two variables or pointers in the case of C++ that have the previous node and the next node in the chain. The first node have none as previous and the last one has the next pointer to none. We could connect the last and first node and have a cycle list. Alright, now let's implement this. We're going to use typing so we can look better what returns what and what accepts what. First, let's begin by creating the node class. Node starts with a value and two pointers to the next and previous node. So in the init function, this is the function that executes when we create a new instance of the class. We have the item value as a parameter, then we define the value with the item value and the next and the pre variables. We use double underscore to make the variables private. Then we define the representation function. This is a string representation of the class that Python uses for various other functions. For example, printing. In this case, we return the value of the node. Great, now let's see the implementation of the linked list. So let's start with the init function. We're going to ask for a list called nodes that defaults to none if not given. So the idea is when we create a new instance of the linked list, we give a Python list, or we can omit that and insert individual items later. We define a head variable to keep track of the first element. We're going to use this for internal functions. So now we're going to loop through the items in the node list and insert to the linked list. So we check if node is not none. We could write this just doing if nodes and Python implicitly see if node is empty, but to make it more clear, I did it this way. So if it passes, we loop and we insert items using the insert function that we're going to define in a moment. We need to use self.dot to use internal functions. Alright, let's see the insert function. We ask for an integer value and we return a node. First, we assert that the type of the value is an integer to ensure that we don't add other types. So first, we create a new instance of a node, and what we're going to do is to add a new item to the beginning of the list using the head variable. So first, we check implicitly if the head variable is not known. Python takes a non value or an empty list as a false value. So here, if we have the head variable defined, we set the previous node to the new node. Now we set the next pointer of the new node to the current head. Then we set the current head to the next node, and we ensure that the previous of the current new head is none. Finally, we return the head. Now, a couple of getting functions. The first function returns the value of the variable head. The next function returns the next node of a given node. This is useful for manipulating the list. Now let's see the pop function. The pop function removes the first element and then returns that node. We do this by referencing the head variable, then we set the new head to the next of the reference head. Then we check if we have a head variable and we set the previous to none. We do this to not have a value error later on. Finally, we return the pop node. For this empty function, we return if the head variable is none. Alright, to finish the linked list, we implement the representation. So here we create a guide starting at the head, and while the guide is not known, we add the value of the guide to our representation string, and then we set the guide to the next node. Then the while is going to stop when the guide is none. Finally, we return the string that we were storing the values. Now let's see how the linked list looks. First, we import the linked list. We use the name of the file, and we import all using the asterisk. Now, check if name is equal to main, so it executes when we run from the terminal. We create a variable called orders, for example, and we create a new instance of a linked list, and we give it a Python list of random numbers. Then we test the first function, and then we get the second node using the next function from the first node. We print the linked list, the first and the second variables, to test their representations. Now let's do a quick implementation to get a better idea of how to use the linked list. We are going to implement find the max of the linked list. So we define a variable for the max and a guide variable to loop over the list. Then while the next node of the guide is not known, we do this. We check if the current max value is less than the next node of the guide. We do this because we started the guide to the start and the max to the start. If we pass, we set the new max to the next node of the guide. Otherwise, we don't do anything and we set a new guide to the next of the current guide. Essentially, we move one along. So let's see if this works correctly. And we also check by putting the max at the first value, the middle, or the last value, so we check that the implementation works correctly. Alright, so this was it. Hope you learned some Python. If you have any questions, comment below, subscribe if you like it, and that's it for me. Bye.